Hello everyone, let's talk about one-way ANOVA. This is another method we need to understand. It's one-way ANOVA, right? So one-way ANOVA, first of all, one-way ANOVA is a special case, right? For linear, it is a special case of linear regression. We can call it as a special case of simple, right? I'll write simple linear regression. So first, second, dependent variable must follow normal distribution. You understand, right? We do hist plot or we check QQ plot. If there is bell shape in hist and diagonal, then it is confirmed that the DB is normally distributed. Or with statistical test, Shapiro will test, we do that, right? For confirming normality where the value should be more than 0.05. So GO goodness of fit test. After that, what we do, what is the thing here? Here 1 dB dependent variable which is continuous. Okay? So and 1 IB independent variable, but there is one more case you need. 1 IB should have some people say 2 or more category, but as per the specific definition I say that 3 plus more categories. So this is the most important thing, right? 3 plus more categories. One, let me give you example. There is a dependent variable called gear. Gear is a dependent variable, and sorry. Sorry, I say MPG, mileage, right? Suppose mileage is a dependent variable, and icons and IB, maybe independent variable is what? Gear, right? 0 automatic, 1 manual, and suppose 2 is off or something, right? No gear at all. Maybe scooty does not have a gear, right? So consider that. 0 means automatic. Automatic means okay, fine. But remember, there should be as per the theory 3, but some people consider it as a 2, right? 2 also okay. Some people say that 2 also okay. So see, independent variable gear. Gear has 0 auto, 1 manual. Okay? 0 automatic, 1 manual. So here we can perform the one-way ANOVA because we have a dependent variable which is in continuous in nature, and we have an independent variable which has 2 or more categories, right? 0 and 1. And actually what happens, why do assumption is there, right? Why we do? We actually see the IMP. Okay, this is important. I say see the difference in mean of each group. Okay, with DB only, I can say DB. So actually what we see the mean of each group difference compare with dependent variable. Okay, so dependent variable maybe gear has a 0 mileage, right? Might be 0 automatic, how much mileage gives, and 1 how much mileage it gives. So ultimately it is comparing the mean. Main things you need to understand: mean of group 0 and 1 with MPG, right? Mileage, right? We are looking the mean. So we can let's form the hypothesis. So F0 what? This is alternative hypothesis. There is no difference in mean, suppose, and one more case is alternative. There is difference in mean. Difference in mean, right? At least, I say at least one has different. So at this type of situation, we use that one way ANOVA. If we have hypothesis kind of there is no difference in mean, I mean to say there is no difference in mileage, whichever gear is used. If we say alternative hypothesis, there is definitely difference as per the gear. There is a difference in mean. So if we talk about programming, right? We have in R, if you say stack R or something R, what we can do is model 1, I can say model 1, AOB, one way ANOVA is AOB, then we'll keep dependent variable. What is our dependent variable? Mine is right, MPG tilde. What is independent variable? Our independent variable is in category, so we use factor. What? Gear, right? Gear. So ultimately we give data as df. So from data, from df, we are extracting two variables, mpg and gear. Mpg is a continuous in nature, and gear has two gear, right? In categorical in nature, that's why we use factor. So ultimately, what we compare is we compare p-value and f statistics p-value. Okay, we'll look at it over there, and based on that p-value, what we can say? Based on that p-value, we can say that if p-value is significant, means it is accepting that there is difference in mean. Okay, at least one pair has a different mean. We have to consider it. If p-value is insignificant, means it says that there is no difference in mean. That how you conclude that whatever the gear you used, but mileage remain the same. That's what it means, alternative hypothesis, right? But in this alternative, null hypothesis, but alternative hypothesis, what it says, at least one pair has a different mean. That means what? Different gear, right? Gear might be, if you used one gear, if you grew 0 gear, right? Maybe there has a couple of gear will be there, right? Right? There has a couple of gear, maybe 2, 3, 4. If I said 0 and 1 only, right? Automatic and manual. But there has a lot of other pairs. 0 gear, you have 3 gears, 4 gear, 5 gear, right? 1 you have automatic, you have 0, 1, 2, 3, 4, 5 gear is there, automatic car, and manual car you have 1, 2, 3, 4, 5 is there. Best it compares the pair, right? Maybe one of the pair has a different mean. Different means based on the gear that mileage can have a different. That's what this alternative hypothesis